Good morning, students. Today, we are going to talk about something that is a little bit unique. They are called inequalities, and they're similar to equations. You'll kind of see why in a moment. But if you want to go ahead and take a moment to pause and copy down what you see here on the screen, this is going to be the introduction video to inequalities. We're also going to continue to use the bottom half of this page to talk about solving inequalities. But go ahead and pause and copy this down so that way you have it in your notebook ready to go. All right. So inequalities are unique because unlike equations, they are representing scenarios that have more than one solution. So let me give you an example of an inequality. And I'm going to kind of use a separate sheet of paper. You do not need to copy this down. I just want you to see and hear an example. So an example of an inequality would be something like this: getting an A in science. So if I asked you to give me a grade that fit this category of getting an A in science, and like, let's just take out the A plus, A minus, situation, any grade that could be considered an A. Someone could tell me a 90. A 90 could be considered an A. Somebody else could say a 100. A 100 is like an A plus plus, right? It's the highest grade you can get. Someone else could say a 91. Someone could say a 93. Someone could say a 95, and so forth, right? The minimum grade you need to get a 90, or I'm sorry, the minimum grade you need to get an A would be a 90. And then it would have to continue all the way until 100, right? So if I said X is your grade in science, if I wanted you to show me a way that you can represent an A in science by using the term X, okay, you would have to say X, your grade in science has to be greater than or equal to 90 in order to be getting an A, right? If I place all the numbers that you told me, 90 is equal to 90, 93 is greater than 90, 95 is greater than 90, 100 is greater than 90. So what this statement is saying here is that your grade in science can be any number, but in order for it to be an A, it has to be greater than. We read the greater than sign, and then this little half sign here means equal to. We'll talk about a little bit more about the symbols in a moment, or equal to 90. This is a way of representing an A in science in a form called inequalities. If we look at another example, here's another example of where we would need to use an inequality because this statement could have more than one answer. So you must be 48 inches or taller to ride the roller coaster. So in order to fit the height description, you have to be 48 inches, you could be 49 inches, or you could be 60 inches, or you could be like super stretchy tall and be 75 inches. Like that would be very, very tall, like it's over 7 feet. But you could even be like not even a full rounded height. What I mean by that is like you could be 51 and a half inches or 57 and 3/4 of an inch, right? You still fit the qualifications of being 48 inches or higher. So in this example, we have multiple answers. So the way that we would represent that, instead of using an equation, because we have more than one answer, we would say, like, let's say your height is X. We would have to say your height has to be greater than or equal to 48 inches tall. If you are 48 inches or taller, you can ride the roller coaster. So you could be equal to 48 inches or you have to be greater than 48 inches. And so this represents this scenario. X can be any number, but you have to be greater than or equal to 48 in order to ride the ride. So you'll notice inequalities are situations where there is more than one solution or more than one answer to the scenario. So what we're going to do now is we're going to look at a couple more examples of inequalities. We're also going to talk about how we can represent these inequalities visually by using a number line. So let's write down the definition. So based on kind of those examples, inequalities are problems with more than one solution or answer. So inequalities, problems with more than one solution or answer. I'm so sorry, it got blurry. There we go. You can take a moment to pause if you want. But inequalities are problems with more than one solution or answer. And in equations, we just called the value of the variable once we figured it out. We just called that the answer, right? Like x equals this, y equals this, and so forth. What we're going to say in inequalities is because the variable could represent a bunch of numbers, because it all just depends on the scenario, we don't call it a solution or an answer. We're going to call it a set of solutions. A set of solutions. Or you could even say solution set if you want to use less words. So in the science and the roller coaster example, with the getting an A in science, the set of solutions was x can be any number. It just has to be greater than or equal to 90. And that's showing all of the numbers that are equal to or greater than 90. In the roller coaster example, the set of solutions was x can be any number. It just has to be greater than or equal to 48 inches tall. So 48 inches or anything taller. So what's important when we use inequalities, as you may have noticed, is the symbols. We're going to be using the greater than, less than, greater than or equal to, and less than or equal to symbols. So here's how they are formatted. X greater than 4, this is the greater than symbol. X less than 4, this is the less than symbol. We're going to read them left to right. So if the smaller part of the symbol is pointed towards the left-hand side, that's representing less than. The opposite would mean greater than. Then if the symbols have this little half of an equal sign, kind of looks like the bottom half of an equal sign, or kind of like an underscore, kind of like a dash, that means whatever the symbol is on top and equal to. So for example, this is saying x is greater than or equal to 4. So greater, and then I'm just going to put slash equal. The other one is less and equal. So that means that the number, whatever it is, could be equal to the other number that's on the other side here. So x could be equal to 4, or it could be any number that's greater than 4. X could be equal to 4, or it could be any number that is less than 4. So that is what these 4 symbols mean. It's really important. So if we look at some examples of some inequalities, we have x is greater than or equal to 48, and we have x is less than 3. That's how we would say these. One thing that we're going to do in this particular section of our unit is we're going to take these inequalities and we are going to graph them. And we're not going to graph them in the traditional sense of like using the coordinate plane. We're going to graph them or represent them on a number line. So what I'm going to do right now is I'm going to draw 2 horizontal number lines. And what I want to do is I want to try to show all of the numbers that could fit into this inequality. So I want to show all of the numbers that are equivalent to 48 or greater than 48 on a number line. So on my number line, I need to have 48 as kind of like a boundary. So I like to just take whatever it is that we're comparing and put it in the center of the number line. So I'll put 48 on this number line and I'll put 3 on this number line. And if I am trying to show all of the numbers that are greater than 48, I'm going to shade the side of the number line that shows all of the numbers that are greater than 48. So let me just put 2 other numbers on my number line to kind of help represent that. Okay. So if I'm trying to show all the numbers that are greater than 48, I am going to shade the side of the number line that has the numbers that are greater than 48. And the number line, the arrows mean that this is going to go on and on forever. So that means my shading would go on and on and on forever. And I think y'all would agree, even like 48.01 is greater than 48. But I also want to make sure I designate whether or not I want to include the number or not. So this is kind of where we need to place a dot or a point on the number line. And depending on what the symbol is, we're either going to use an open or a closed dot. So an open dot is when we're using the greater than or less than symbols. We are not including that number as part of the solution set. Therefore, we're just going to put an open dot on it so you know that this is kind of the guiding point, but this is not included in our solution set. Versus a closed dot is where we're going to use the greater than and equal to and less than and equal to symbols because we want to make sure we include that number in the solution set. So for the inequality, x is greater than or equal to 48, we're going to put a closed dot on 48 because we're trying to show the number could be equal to 48, but it could also be equal to anything that's greater than 48. So if we look at the second example, x is less than 3, I'm just going to kind of label 2 other numbers on my number line here. If I want to show anything that is less than 3, I'm going to shade the side of the number line that has all the numbers that are less than 3. And again, the arrow means that it would go on and on in this direction, even into the negatives. But since x is less than 3, that means 3 is not included. So 2.99999999999 that goes on forever is less than 3. But once it hits 3 itself, not included anymore. So I'm going to do an open dot and not shade it in. So that way we know this is kind of the boundary point 3, but it has to be less than 3, and 3 is not included in that amount. So as you can see, inequalities are a little bit more complex just because they're representing multiple numbers. We're not saying that x is equivalent to this exact number. There's only one solution. We have multiple solutions or answers to our problems based on the different scenarios. So we talked about a scenario where you get a certain grade in a class. We talked about a scenario of you have to be a certain height to get on a roller coaster. You could have some sort of scenario where, in order for John to be able to leave practice, he has to make more than 15 free throws. So that would mean if he made 15, it doesn't count. He has to make more than 15. So we would have to use the greater than symbol. So anything that's more than 15. So 16, 17, 18, 19, he has to make more than 15 in order to be able to leave practice. That's another example of an inequality. We can represent inequalities on a number line because we're showing all of the values that could fit in the solution set. Because even decimals and fractions, right? Like 48.5 is greater than 48. 2.5 is less than 3. It doesn't have to just be whole numbers. So this is your introduction to inequalities. I'm going to try to link in the description bar some other websites for you to kind of look through if you are having a little bit of trouble understanding the difference between an inequality and an equation. Essentially, equations have one solution, inequalities can have multiple solutions. And in the next video, we're actually going to talk about how we solve inequalities. So we're going to have this kind of bottom page set up. We're not going to do that in this particular video. We're going to talk about how we would solve them, how we would solve for this set of solutions. How can we figure out what does x have to be greater than, less than, equal to, and so forth. So there's no practice problems for this video. I will give you the practice problems in the next video. So go ahead and make sure you review your notes, ask your teacher if you have any clarifying questions. And as always, I hope you have a great day wherever you are and whatever you're doing while you're watching this video. But now you're not, because it's over. Bye.